Hello everyone, and welcome to Building a Hybrid Data Platform with Azure Arc enabled data services. To begin with today, we'll start with an introduction to Azure Arc and data services for those that haven't already heard about it. Then we'll dive deep into how to deploy and manage data services on any infrastructure. Along the way, we'll do lots of demos, and then we'll have some time at the end for Q&A. Let's dive in. Really, hybrid cloud is the new norm these days. One of the reports that I keep an eye on is the Flexera State of the Cloud report. And in that report, it tells us, year over year that about 75% of organizations are adopting a hybrid cloud strategy. And within those 75%, we can see that about 93% of companies are using either multiple public clouds or multiple private clouds or both. And really, that complexity introduces a lot of challenges. The real opportunity there and the challenge is to how to manage all of these things at this scale. Because really, when you're using something like AWS, you have one tool set and process of how you do things. When using Azure, you have a different tool set. You have a different tool set for how you do things on premises. So how can we really get our hands wrapped around our entire infrastructure and services and manage it in an easy way? Really, what people tell me is, how can I get these benefits of the cloud that I really love, but really get them everywhere? How do I get things like elastic scalability, self-service provisioning, built-in monitoring and security, paying just for what I use, management from anywhere, and automation at scale? So I want to show you how Azure Arc enables you to realize all of these cloud benefits on any infrastructure. You probably have some infrastructure in your own data center or an edge site location like a retail store, or maybe you're using something like Azure Stack Hub or Edge, or maybe you're using public cloud infrastructure in AWS or GCP. You probably have some virtualization layer on there. And with Azure Stack HCI, that's really where we can start to see Azure Arc come to the picture and help you manage Azure Stack HCI from Azure. Then on top of there, you can deploy your servers, whether it's virtual machines or physical servers, and then install the Azure Arc agent into those servers, which will securely connect them to Azure and make them manageable by Azure. And we have specific solutions built for SQL Server to help you manage your SQL servers wherever they might be. Then you can take your Kubernetes clusters, whether it's an OpenShift cluster on premises or AKS running on Azure Stack Hub or a managed Kubernetes service like EKS or GKE, and install some Kubernetes agents into those Kubernetes clusters to help you manage them from Azure. And that also works for AKS running on HCI as well. Now, on top of any of these Kubernetes instances that you might have, you have your data services deployed. And Azure Arc enabled data services allow you to provision and manage SQL managed instances and Postgres instances on any infrastructure from Azure. Once you connect these things up to Azure, then you can really start to take advantage of the Azure management services, things like grouping them together into resource groups, using Azure Backup and Azure Monitor, authenticating using Azure Active Directory, and so on. Now, a couple interesting things about this is that if you choose, you can get a full stack that's provided and supported by Microsoft on any infrastructure you want, as long as it's on some sort of certified hardware for Azure Stack HCI. Or you can choose to get the hardware itself even from Microsoft and our OEM partners with Azure Stack and get a fully supported solution top to bottom, supported and provided by Microsoft along with our OEM partners. So let's dive in detail here on data services. Data services helps you always stay current through self-service provisioning of the latest version of SQL Managed Instance and Postgres, automatic updates which keep you up to date with the latest updates and features, and you never worry about going out of support with the evergreen SQL instance because we're always keeping it up to date. And you never have to worry about SQL Server going out of support recently for SQL Server 2008. Another benefit of this is that you have the elastic scalability. So you can provision a Postgres Hyperscale instance, for example, and scale out your data across multiple physical machines to really get that performance for those applications which demand it. And you can also scale up and down the amount of compute resources that you're using and pay just for what you use based on the demand for the application at a given point in time. And then lastly is you get a unified management experience. You get a unified set of tools and experiences which are consistent across all of your environments and across all the different database engines that you're using. And the management services and monitoring and security, they're all built in. And importantly, this is available to you to run in either an Azure connected mode or in a mode where you're disconnected from Azure, giving you the flexibility to consume these services in a way which meets your requirements. Now, let's take a look at self-service provisioning in detail here. So when we go to deploy something into a Kubernetes cluster, we have some Kubernetes nodes, which are providing the compute capacity, and some remote storage typically. And then there's a Kubernetes API server on which we are going to send our tasks to be deployed, right? And we have a set of tools here like Azure Data Studio or the Azure Data CLI tool, which can be used to do these provisioning tasks. And they will connect up to the Kubernetes API server and provision those database instances onto the Kubernetes cluster. Now, another pattern which we want to talk about here today is this idea of doing CI/CD through Git. And this pattern is called GitOps, where we check in a Kubernetes YAML file which describes a SQL instance that we want to be deployed, for example. And the Azure Arc-enabled Kubernetes agents that are running on our Kubernetes cluster will be continuously looking up there at that Git repository for any changes that happen and pull those YAML files down and apply those to the Kubernetes API server to provision a database instance. Okay, and then another way where we can deploy things is from the Azure portal or the Azure CLI. And the way this works is that some Azure Arc-enabled Kubernetes agents are monitoring Azure looking for deployment requests which have been submitted by users. And when those deployment requests come in, the Kubernetes agents then talk to the Kubernetes API server to provision those database instances. And this ensures that the connectivity always initiates within your secure environment and pulls Azure looking for those deployment requests. And the really great thing about this approach is that you can do these types of tasks from anywhere. You could be on a laptop in a coffee shop or on an airplane, anywhere where you have access to Azure through the Azure portal. This also is something that we call the directly connected mode. And the directly connected mode is not yet available in preview, but we will make that available in preview here very soon. Let's take a look at how we could subdivide and distribute our data services across many different infrastructures. So let's take this and just divide it into an on-premises environment, a public cloud infrastructure, and maybe an edge site. And each one of those will have a Kubernetes cluster with its own Kubernetes API server. And then we can use our tools, Azure Data Studio or the Azure Data CLI, to connect up to those Kubernetes API servers and manage them as one sort of experience inside of that tool. And we can still use our GitOps pattern where we deploy Arc-enabled Kubernetes agents onto each of these Kubernetes clusters so that whenever we merge in a change, those Arc-enabled Kubernetes agents are picking up those changes and applying those to the Kubernetes API server to provision or update our database instances. And of course, the directly connected mode works the same way, just at scale now across multiple Kubernetes environments by having those Arc-enabled Kubernetes agents monitor for those changes that are happening inside of the Azure portal to be pulled down and apply those to the Kubernetes cluster so that we can deploy or update those database instances. So let's take a look now at a demo of how all of this works by using Azure Data Studio. So here I've got 4 terminal panels across the bottom. Each of these is going to help us keep an eye on our Kubernetes environment as we do some provisioning tasks. The first is a AZ Data Arc SQL MI list. Then we've got kubectl get persistent volume. Then we've got kubectl get service. And then over here, we have an interesting command, which is we're using kubectl, which is a native Kubernetes tool, but we're getting PostgreSQL 12 instances. So this is a custom resource definition that we've extended Kubernetes data model with to help us manage our PostgreSQL instances inside of Kubernetes. So let's go ahead and kick all these off now so we can keep an eye on what's going on. And you'll see here that we actually currently have no SQL managed instances deployed in this Kubernetes environment here. And I'm going to kick off the deployment wizard here inside of Azure Data Studio. You can focus in here on the 2 different data services, SQL managed instance, as well as PostgreSQL server groups. We'll select SQL instance and select the box. This will bring up a simple form where we can provide the administrator username and password. And then I'll choose the storage class here. In this case, I'm using AKS, so I'll choose the Managed Premium Storage class and kick off the deployment. Now, once this deployment is kicked off, we can go and keep an eye on the leftmost panel here, and we can see the SQL instance show up here in our list of SQL instances here in just a second. Okay, there it comes. So there's our SQL instance. It's in the creating state currently. We can see over here the persistent volume claims have been created for it. You can see that the services have been created to expose that service so we can connect to it. And now, this is a great experience for GUI, but I want to show you how we can do things with the CLI so we can automate things. Here we've got AZ Data Arc SQL MI create, and we're going to pass in the name and the storage classes just like we saw in the wizard. But in this case, we're using the CLI tool so we can automate things. Then we have the Postgres server create command as well. We're going to kick off both of these with the notebook here. I want to point out how these commands are essentially the same between SQL MI create and Postgres. And the idea here is to really keep a consistent user experience between these so that regardless of which database engine you're working with, the experience is the same. Okay, so we can see now down here in the leftmost panel that the new SQL instance 2 is created. We can see its persistent volume claims and services. And then we can see our Postgres instance showing up over here on the right. So this is good for sort of at one at a time or whatever, but we can also use this to do things at scale. I've got a file here that just contains a list of clients that we want to onboard to our service and create a database instance for each of them. We can read that file in and then pass it to the AZ Data Arc SQL MI create command to create a database instance for each of them. Now we can see the database instances will start to show up here in the lower left panel, starting with the blue Yonder client. And then if we give it a few more seconds, we should be able to see the Contoso database instance come up as well. And we can see that the persistent volume claims and services are all being created for us automatically, so we can do all of these types of things at scale. Here in another Azure Data Studio window, I want to show you how we can do things in a Kubernetes native way. Here I've got a YAML file that describes a SQL managed instance and its associated administrator username and password that we want to use to create the SQL instance by applying this Kubernetes YAML file to our Kubernetes cluster. Here we can see the secret that has the SA password in it. Here you can see that we're creating a custom resource based on the SQL managed instance class. Now you can see the file here, SQL GitOps1.yaml. This is the file we're going to check into our Git repository. And down here we've got these 3 panels which are going to monitor 3 different Kubernetes clusters, each of which has the Arc-enabled Kubernetes agents deployed on them. So we're going to just fire up an environment variable here that will set the context to each of these 3 different Kubernetes clusters. And then we'll go through and we'll run a command here which will do a list of all of the SQL instances present in each of these Kubernetes clusters. And to begin with, we have no SQL managed instances in any of these environments. But as we check in this YAML file here, we'll see that the Arc-enabled Kubernetes agents will pull that down and apply it. So let's go ahead and do a commit comment here. And we'll commit this into our Git repository. And we'll push this up there. And now within a few seconds, what we'll see happen here is that the Arc-enabled Kubernetes agents, which are monitoring that Git repository for changes, will see those changes be applied and pull this Kubernetes YAML file down and apply it to the Kubernetes API server to create the instances in that Kubernetes cluster. Okay, so there we go. The first couple are now being created in the first 2 environments there. And within a few more seconds, we should actually see the SQL instance show up in the 3rd environment. And there we go. So now we can see how we can deploy SQL instances at scale using a GitOps pattern where we check in a Kubernetes YAML file, the Arc-enabled Kubernetes agents are monitoring for that, and deploying things in a desired configuration pattern where we can use Kubernetes native abilities to provision these custom resources to create these SQL managed instances for us. So let's take a closer look now at elastic scalability and that ability to both scale out as well as scale up and down. Let's start with scaling up and down. So we can use these tools we've seen so far, like the Azure Data CLI as well as Azure Data Studio, to provision things. We can specify the number of cores and the amount of RAM we want each of those instances to have. And Kubernetes will then deploy that instance onto some Kubernetes node which has the available capacity to run that instance. And when it does that, it'll create what we call a persistent volume claim, which mounts the storage where the data files are located to that pod so that the database engine can access them. But now let's say we want to come along and scale that instance. Somebody else could come along using Azure Data Studio, for example, and they could edit that instance to change the number of cores from 4 to 20, for example, and maybe bump up the amount of RAM. And what Kubernetes will do in that case is it will take down the original pod, and then it will redeploy another pod, which has that additional capacity available to it, and it will mount that persistent volume claim to it so that it can continue to see those database files, but now it has more compute and RAM capacity available to it. Now, in the current preview, this of course involves some application downtime because we're taking a pod down and redeploying another pod. But as we introduce high availability in future releases, we'll have multiple instances, and we'll go through a rolling upgrade procedure to update those instances to the new compute capacity so that you never have any application downtime. Now let's take a look at how we could actually also do this through the GitOps pattern, because at the end of the day, it's just a kube control edit, effectively, where we're changing the configuration of that SQL instance. We can also do it through the Azure portal or the Azure CLI using the directly connected mode. Okay, so now let's take a look at how PostgreSQL Hyperscale helps us scale out. So to begin with, we might deploy, using the tools we've talked about, a new PostgreSQL Hyperscale server group, which has 2 worker nodes. And Kubernetes will schedule those to land on 2 different Kubernetes nodes. That way we can take advantage of scaling out across multiple sets of compute underneath those virtual machines or even physical machines. Now, let's say that we want to scale that out and add some additional nodes. Somebody could come along and edit that PostgreSQL Hyperscale server group to add some additional worker nodes and take it from, let's say, 2 workers to 4 workers. And Kubernetes will then provision some additional worker pods onto some different Kubernetes nodes. So we're scaling out, again, across multiple server nodes, each with their own compute capacity. Once we've done that, then we can kick off the rebalancing process, which will rebalance the data across those different nodes. And of course, we can do this through the GitOps pattern and through the directly connected mode as well. So let's take a look at a demo of data services using elastic scalability. So here I am in another Azure Data Studio window. And here I've got a connection to a Postgres instance, PG01. I've got a database here called Postgres, and I've got a table called GitHub Events. And this table has just a couple of columns on it for some IDs to store the events and the repo ID, and then a JSON-B data type column to store the JSON events as data. Now, what I'm going to do is I'm just going to run some basic queries against this database instance. Here, we're going to do a select query. This is just a very standard SQL query, except for one thing, which is that this is a distributed query, which is running across multiple nodes. So we're actually running that query across multiple worker nodes and bringing that data back together into a single query result. Now we'll run a different query here, which is going to join together the JSON data with the traditional relational data. And again, this query is executing as a distributed query across multiple nodes. So let's take a look at the data distribution, and we can see here that the data is pretty evenly distributed across these 4 worker nodes. You can see that visually here in the chart. So now let's take a look at how the Kubernetes cluster is actually configured before we run the rebalancing and scaling operations. So here we've got a coordinator node and 4 worker nodes that are distributed across multiple Kubernetes nodes, so we get scale out performance across those Kubernetes nodes. Now what we're going to do is we're going to actually scale this out by using the AZ Data CLI. So we'll run a command here, AZ Data Arc Postgres server edit, and we'll pass in the name PG01 and set the worker node count from 4 to 8. So this will now kick off Kubernetes, and it'll deploy these additional 4 pods for us. And that will allow us to scale out the data and just redistribute it across those nodes. Now, while that scaling operation is happening, let's run some queries here. And you can see that, of course, these queries continue to work because we haven't actually touched the data yet. We're just scaling. So we're just adding additional Postgres nodes to the Kubernetes cluster. Nothing's happened with the data yet. Let's kick off the rebalancing process now. So with the rebalancing process, the data is actually going to start moving from the original 4 nodes and redistributing evenly across the other nodes. And we can see that redistribution happen from those 4 nodes to now these 8 nodes. So you can see that as we start running these queries over and over, there's a couple things here, right? One is we're still able to run queries over this data, even though the data is moving around. And we can see that the data is being evenly distributed over time. Now we can see that the data is evenly distributed across all of these Postgres worker nodes. And if we go and look at the node configuration again now, we see that we have these additional Postgres worker nodes, and they're deployed across now 8 different Kubernetes nodes, which gives us that scalable performance for our database. So that shows you how PostgreSQL Hyperscale can scale out across multiple nodes. Now let's pivot and start talking about the built-in management capabilities and how it gives you the flexibility of using these management capabilities, whether you're in a mode which is connected to Azure or disconnected. We haven't really talked about this yet, but one of the key components of the architecture is what's called the Azure Arc data controller. And the data controller is a set of Kubernetes pods that are deployed on your Kubernetes cluster that provide services like the actual brains of the operation, the controller service, as well as an API, and Kibana and Grafana dashboards to visualize our monitoring data. And as you deploy these SQL or Postgres instances, an agent is deployed along with them, which collects the logs and metrics data and brings that back to the data controller so that you can then visualize it using the Kibana and Grafana dashboards. And this management experience is all provided local to that Kubernetes cluster, wherever it might be. Now, in addition to that, you have the option of exporting out the inventory and billing information and the metrics and logs and uploading that to Azure so that you can then see it in the Azure portal. And this will be an automated process in the directly connected mode as we introduce that in the future. So let's take a quick look at the differences between the indirectly connected mode, which is available in preview now, and the directly connected mode, which will come in the future. In the indirectly connected mode, all the management capabilities are local. So you get local monitoring, local backup restore, local log analytics, local self-service provisioning. And you can use Kubernetes for authentication and authorization. And then you can optionally upload that data to Azure, so you can see it in the Azure portal. And then we'll have more details for you on the directly connected mode when that becomes available. So let's take a quick look at a demo of what this management experience looks like for managing your hybrid data estate at scale. All right, so here in another Azure Data Studio window, I've set up a connection to each of 3 Azure Arc data controllers, one in EKS, one in GKE, and one on premises. This allows us to manage all of our environments from one point here inside of Azure Data Studio. We can see each of the different database instances that are managed by these data controllers. And through automation, I've set this up so we have the same set across all. Here we can right-click and manage and go and view the details about this data controller as well as all the instances that it's managing. We can click in on one of these to see the details about that particular database instance. And then we can view either the Kibana or Grafana dashboards by just clicking these links. Let's drill in here to take a look at the Grafana dashboard. Here for this particular instance, we can see all the transactions per second, the wait statistics as we'd expect. And this is the local monitoring experience that you get even without a connection to Azure. But if we want to connect to Azure, we can go right from Azure Data Studio, open it in the Azure portal, and actually see this instance right there in the Azure portal and see the same details about it, right? And then we can drill into something like metrics, let's say. And in this case, I've uploaded the metrics information to Azure. So we can actually see those same metrics here inside of the Azure portal and see those initial data points that are collected about that instance we just provisioned there. Now, the really great thing about the Azure portal is that we can view all of our instances that are being managed across our entire data estate in one place. So each of those data controllers, I exported out the data, uploaded it to Azure. So here we can get a single view of all of our database instances across all 3 different environments right here inside of the Azure portal and manage them all from one place. Whether it's with the portal or the ARM APIs or the Azure CLI, we can manage everything in one place here. So this really shows the power of Azure Arc enabling our data services because we can manage all of our data services regardless of which environment they're running in from a single point of control here. All right, so in these demos, you've seen how Azure Arc-enabled data services helps you realize those cloud benefits everywhere. You get the benefits of being able to do self-service provisioning, automation at scale, elastic scalability, and paying just for what you use as you scale those things up and down, the built-in management and security. You've seen all this stuff in demos, but now you have the opportunity to go try this out for yourself because Azure Arc enabled data services is in preview now. So you can go to aka.ms/Azure Arc Data and try it out for yourself and give us feedback on what you think about it. As we go forward, there will be monthly releases where we'll continue providing new features and updates and responding to your feedback. So with that, let's take a few minutes for Q&A. Thanks everyone for joining. All right, well, thanks for joining us for the question and answer period here. We've got some of the program managers for the team joining us. We've got JY, Vin, Dhananjay, and Dinakar. Dinakar is going to be the moderator for the session. So Dinakar, what questions do we have so far?
Yeah, so the first question we have is, can you tell us more about the pricing and how the billing will work?
Yeah, so the way to think about that is that the billing is a pay-as-you-go pay just for what you use, cloud-like billing model, and it's based on the number of cores that your database instances are consuming. And so as you provision those database instances, you'll specify the number of cores you want to have available to them, and you can change that over time as your needs change. And then all of that billing information is sent to Azure, and it just gets billed through Azure, just like all the other Azure services that you use today.
So the next question is, are Arc data services designed for service providers such as multi-tenancy, etc.? Dhananjay, do you want to take this one?
Yes, Dinkar. Arc-enabled data services are designed for service providers. And when I say service providers, let me explain. It means enterprises which may have departments, or a company which has several departments under the same cloud, or companies which are businesses as service providers that are hosting other companies' cloud services. So it is designed for service providers. Usage reporting, billing, unified billing, all of this is multi-tenanted. And it's integrated with Azure Lighthouse, which is designed for managed service providers, as well as works with Azure Stack.
Okay, thank you. The next question is, does Microsoft provide support like in Azure PaaS, and how about any SLAs? Travis, do you want to take this one?
Yeah, the way to think about that is that customers are the ones that are providing the infrastructure when it comes to Azure Arc-enabled data services. And then Microsoft is providing the software that you run on that infrastructure. So Microsoft will support the software part of it. You can call us and talk to our support team, much like you would any of our enterprise software. Anytime you have a problem, we'll help you work through that. But because we don't own the entire stack, sort of top to bottom, because you're providing the infrastructure, we can't really provide these SLA guarantees like we do in our PaaS services in Azure.
Sounds good. The next question is on Postgres. Is Postgres Hyperscale different from regular Postgres? And the second part of the question is, will my existing Postgres databases just work in Hyperscale? JY?
Yes, thanks, Dinakar. Yes, Azure Arc enabled Postgres Hyperscale is a little different from quote standard Postgres in the sense that Postgres Hyperscale uses a Citus extension to Postgres to transform Postgres into a distributed database. The Citus extension, which is now a Microsoft extension, actually distributes the data and the queries across all the nodes in the cluster. Right? So from that perspective, if you get your data into Postgres Hyperscale, yes, your application and database would function normally. However, you would not benefit from the scale-out capability and the additional performance until you distribute the data, until you implement some of the commands that you need to do that, and we document, which is choosing a distribution column and sharding the data. Right? But other than that, your data and application will work as is, yes.
The next question is on SQL Server. The question is, can I migrate my SQL Server databases on premises to Azure SQL Managed Instance? And if so, how? Well, do you want to take this one?
Yeah, sure. Great question. And yes, you can migrate your SQL Server workloads into Arc-enabled managed instance. It's as simple as taking a backup from SQL Server and restoring it to Arc-enabled managed instance. We'll be working on more options in the future, so stay tuned.
Okay, thank you. And the last question is, do I have to have certain kinds of hardware, like in Azure Stack or something else? Dhananjay, do you want to take this one?
No, you don't need any special hardware for running Azure Arc-enabled data services, but you do need to meet the minimum requirements of 16 GB and 4 core. As Travis mentioned in this talk, you can get a fully supported stack with Arc running on Azure Kubernetes Service on Azure Stack HCI, but we also support on any of the upstream Kubernetes flavors that run on any of the supported hardwares, as long as you meet the minimum requirements, including Azure Stack.
Okay, thank you. That's all the questions we have. And Travis, do you have any last minute comments?
Yeah, thanks for everybody for the great questions. We have an Ask the Expert session here at Ignite as well. So that's a full 30 minutes, I believe, where we can answer any further questions that you might have. So please join us there. Thanks for joining the session, everyone.